capacitance also depends upon the size of the conductor. When they increase the diameter, resolving power also increased. For one particular voltage, the depletion region breaks down, current increases, so the depletion region will decrease. Radioactivity does not depend on the time of creation. So the next question, students. The electric flux for Gaussian surface A that enclose the charged particles in free space. So here is a diagram which encloses a Gaussian surface. It encloses charges Q1, Q2 and Q3, and the magnitude of Q1, Q2 and Q3 is given. I have to find the electric flux across that closed surface. So wherever you have a Gaussian surface, wherever you have charges, how will I find the electric flux? We know electric flux is 1 by epsilon naught times the total charges enclosed. Idane karitive Gauss law of electrostatics. Electric flux equals 1 by epsilon naught times total charges enclosed. So this is total charges Q1. So minus 14 nanocoulomb plus Q2. Adana approximate age 79 ant barkoltini. Minus 56. All of them in terms of nanocoulomb divided by the value of epsilon naught, 8.854 into 10 power minus 12. So this is, if you observe, 79 minus 56 minus 14. Approximately 9 barutte. Take this to be nearly 9. 9 and 9 gets cancelled. This is 10 power 3, and which is the suitable SI unit. It is Newton meter square coulomb minus 1 electric flux. So the first option is correct. Next one. 4 metal conductors having different shapes. 4 metal conductorಗಳಿವೆ. They have different shapes. Which are the shapes? 1 spherical conductor, 2 cylindrical conductor, 3 pure, and 4 lightning conductor. So there are 4 given conductors with this shape. They are mounted on insulating stands and charged. ಈ 4 ಕಂಡಕ್ಟರ್ಗಳನ್ನ insulating stands ಮೇಲೆ mount ಮಾಡಿ, they are mounted on insulating stands and charged. The one which is best suited to retain charges for a long time has to be a sphere. Why? Since it has a uniform surface, the charges quickly distribute themselves on that uniform surface. So, maintaining the charges for a longer time is possible. So, here the answer is pure. The potential to which a conductor is raised depends upon. So, the expression for potential is V equals Q divided by C. Q, amount of charges stored. C, capacitance. So naturally, first it depends upon the amount of charges stored. But what does capacitance depend upon? Naturally, shape of the conductor. Adana, geometry of the conductor and karitivi. Capacitance also depends upon the size of the conductor. So potential depends on amount of charges stored. It depends on geometry, that is the shape of the conductor as well as the size of the conductor. So here the answer is both 1 and 2. Work done to move a charge Q once round a circle of radius R with charge Q at the center, equipotential surface. Work done to move a charge on an equipotential surface is 0. So the answer is none of this because it is 0. A air-filled parallel plate condenser. Condenser is nothing but a capacitor. Capacitor ne condenser ant karitivi. Air-filled parallel plate condenser has a capacity of 2 picofarads. Air-filled, when the space between the plates is filled with air, adane air-filled capacitor ant heltivi. The capacity is 2 picofarad. The separation between the plates is doubled and the space is now filled with wax. The capacity increases to 6 picofarads. What is the dielectric constant of wax? Andre, initially it is the air medium. No material medium. So what is the capacitance of an air-filled PP capacitor? C equals epsilon naught A divided by D. What is C in first case? 2 picofarad. So epsilon naught A divided by D. Next, the separation of the space is doubled and the space between them is filled with wax. Now, material medium, epsilon naught, epsilon RA. Now the space is doubled. So capacitance in this case is 6. So epsilon naught, epsilon RA by 2D. Divide this expression, epsilon naught, epsilon D and D gets cancelled. So you have a 2. So epsilon R is equal to 6. So the answer is the fourth one, which is 6. Identify the wrong statement regarding Coulombs law. Coulombs law ಎಲ್ಲರೂ ಕೇಳಿದೀವಲ್ವಾ? ಈ 4 ಆಪ್ಷನ್ಗಳಲ್ಲಿ ಕೂಲಂಬ್ಸ್ ಲಾ ಬಗ್ಗೆ ಇರುವ ರಾಂಗ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಕಂಡುಹಿಡಿಬೇಕು. Coulombs law explains how electrons of an atom are binded in the nucleus. Alva? Binded to the nucleus. Yes, it is giving the condition where it says electrostatic force between the nucleus and the electron is equal to centripetal force. Yes. It explains how atoms binds together to form molecules. Yes. How molecules form new solids. True. But it never explains how the nucleons are present inside the nucleus. It never explains the characteristic of nuclear forces. Therefore, the option which is wrong is B, how protons and neutrons are present in the nucleus of an atom. This is an assignment for you all. Young's double slit experiment. Same problem with respect to single angular slit is done. The answer is 3Y. Please to refer to that. At Kavalur in India, it is a space station. The astronomers using a telescope whose objective had a diameter of 1 meter started using a telescope of diameter 2.54 meter. This resulted. So initially at Kavalur, the astronomers used a telescope whose diameter was 1 meter. ಅದರಿಂದ ಏನಾಯ್ತು? ಅವ್ರಿಗೆ ಡಿಸ್ಟೆಂಟ್ ಆಬ್ಜೆಕ್ಟ್ಗಳು, ಸ್ಟಾರ್ಗಳು ಸರಿಯಾಗಿ ಗುರ್ತಿಡಿಲಿಕ್ಕಾಗಿಲ್ಲ. ಆಗೇನ್ ಮಾಡಿದ್ರು ಅವರು? They used telescopes whose diameter was 2.54 meter. ಆ 1 meter diameter ನ ಬಿಟ್ಟು they use telescopes of diameter 2.54 meter. ಆಗ ತುಂಬಾ ಚೆನ್ನಾಗಿ ಫಾರ್ ಅವೇ ಆಬ್ಜೆಕ್ಟ್ಸ್ ಕಾಣಿಸ್ತು. ವೈ? When they increase the diameter, resolving power also increased. So the increase in the resolving power 2.54 times for the same wavelength. So our diameter objective in a diameter na increase ಮಾಡ್ತಿದ್ದ ಹಾಗೆ resolving power increase ಆಯ್ತು. That is why they could focus distant objects clearly. When unpolarized light is incident from air onto glass at the polarizing angle. What happens at the polarizing angle? Definition of polarizing angle. It is the angle of incidence for which reflected light is completely polarized. Alva? Brewster's law ಓದ್ತೀವಿ. Polarizing angle ಅಥವಾ ಬ್ರೂಸ್ಟರ್ಸ್ ಆಂಗಲ್ ಅಂತ ಓದಿದ್ವಿ. ಏನ್ ಬ್ರೂಸ್ಟರ್ಸ್ ಆಂಗಲ್ ಅಥವಾ ಪೋಲರೈಸಿಂಗ್ ಆಂಗಲ್ ಅಂದ್ರೆ, ಆ ಒಂದು ಆಂಗಲ್ ಅಲ್ಲಿ ಇನ್ಸಿಡೆಂಟ್ ಲೈಟ್ ಬಿದ್ರೆ ರಿಫ್ಲೆಕ್ಟ್ ಆಗಿರೋ ಲೈಟು ಕಂಪ್ಲೀಟ್ ಪ್ಲೇನ್ ಪೋಲರೈಸ್ ಆಗುತ್ತೆ. 100% plane polarize ಆಗುತ್ತೆ. So here the reflected beam is polarized 100% completely. That is what is called polarizing angle. The right option is Maxwell provided theoretical evidence that light is a transverse wave. Yeah. Two coherent beams of intensity I and 4I are superposed. ಎರಡು coherent beamಗಳನ್ನು ತಗೊಳ್ತಾರೆ. One of them has intensity I, the other has intensity 4I, and they are superposed. The maximum and minimum possible intensities in the resulting beam. ಮೊದಲನೇದಾಗಿ ಇಂಟೆನ್ಸಿಟಿ ಮತ್ತೆ ಆಂಪ್ಲಿಟ್ಯೂಡ್ ನ ಯಾವ ರೀತಿ ರಿಲೇಟ್ ಮಾಡ್ತೀವಿ? ವೆರಿ ಗುಡ್. ವಿ ನೋ intensity is directly proportional to amplitude square, which means root of I is proportional to A. So ನಾನಿಲ್ಲಿ A1 by A2 ಅಂತ ಮೆಜರ್ ಮಾಡಿದ್ರೆ root of I divided by 4I. So this is equal to root of 1 by 4, which is half. So I have A1 by A2. So maximum and minimum possible intensities. So maximum intensity, so I max now is equal to A1 plus A2 whole square divided by I minimum, which is equal to A1 minus A2 whole square. So this is 3 by 2 minus 1 whole square. So this is 9I and I. So the answer is 9I and I. From the figure describing photoelectric effect, what do we conclude? If you observe, it is a graph of frequency versus stopping potential. So maximum kinetic energy ಆದ್ರೂ ಆಗಬಹುದು, stopping potential ಆದ್ರೂ ಆಗಬಹುದು. They are directly dependent on frequency. So maximum kinetic energy for both the metals depend linearly on the frequency. So this is an expression went to grace marks. None of the options hold good. So, but I'll tell you, time period of revolution of an electron in an hydrogen atom is directly proportional to n cube. Transition is happening from n1 to n2 state, our prakara. And the time period of electron in the initial state is 8 times the final state. Andre 8 by 1 is, from n1 to n2. So taking cube roots, it has to be 2 and 1, which is missing here. In the forward voltage in a diode is increased, width of the depletion region. Now bias voltage increase ಮಾಡ್ತಿದ್ದಂಗೆ depletion region ಕಡಿಮೆ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. potential barrier kammi agutte. For one particular voltage, the depletion region breaks down, current increases, so the depletion region will decrease. Two nucleons are separated by one Fermi distance. ಎರಡು ನ್ಯೂಕ್ಲಿಯಾನ್ಗಳಿದೆ, one Fermi distance ಅಲ್ಲಿ separate ಆಗಿದೆ. Protons have a charge of 1.6 into 10 power minus 19 coulomb. The nuclear force between the protons is F1. If both are neutrons, F2 is both are protons, F3 is one is proton and the other one is neutron, the nuclear force between them is the same because nuclear force is charge independent. Until and unless the two nucleons are separated by one Fermi distance, they will have the same nuclear force, so they are charge independent. De Broglie wavelength, same question I worked out in the previous session. It has to be thrice the initial energy. Mean life of a radioactive sample is 100 seconds. Then what is its half-life in minutes? So we have T half is T divided by 1.44. Know this relation? Half-life and this is mean life. So this is 100 divided by 1.44, approximately 70 seconds. But this has to be converted into minute. 70 divided by 60, nearly 1.155 is the answer. Now, the probability of decay, radioactive decay, is always independent of the time of creation. Decay, radioactivity does not depend on the time of creation. Bohr's atom model assumes nucleus is of infinite mass and at rest. True. Electrons are quantized, will not radiate energy. True. Mass of the electron remains constant. True. So all the above conditions. Identify the property which is not characteristic for a semiconductor. Charge carriers, holes and electrons are in the valence band at high temperatures. This is not the characteristic. So students, we saw again how it was only assertions and concepts that helped me to solve this 2005 paper. Next, we come up with 2004. Until then, have a nice time. Thank you.